This tutorial is for those of you taking pharmacology as a course. In this video, I'm going to be focusing on this certain drug which we call the digoxin, though some people choose to pronounce it as digoxin. Digoxin or digoxin, regardless of how you pronounce it, feel free to write it correctly. We're definitely going to meet at the spelling. Digoxin falls under the class of cardiac glycoside. Specifically, it is a digitalis glycoside. Notice that the word cardiac simply means heart or anything related to heart. And this refers to heart function and health. Example, we have the cardiac arrest, cardiac surgery, and cardiac medication. And the word digitalis here basically is a medicine that helps the heart to work better. This common gland. Notice that the guns present like heart failure and arterial fibrillation. Heart failure, this is which blood meet the body's need or desire. I felt a simple heartbeat. The disease will make up more efficiently. Some basic of digoxin in quantity, slow heart rate, and improved blood circulation. Increasing the heart's contractility. The digoxin strengthens the heart's ability to pump blood. When we have enough blood out of the heart, that is contraction. What about slow heart rate? This particularly is useful in cases of atrial fibrillation, where the heart beats so fast or too fast. Then the last one, it improves blood circulation. Notice that with a stronger heart and a slower, more efficient beat, your blood circulates better, delivering oxygen to all parts of your body. Digoxin mechanisms of action actually start by targeting the sodium-potassium pump ATPase on cardiac myocyte. Next thing it does is increase the intracellular sodium concentration and messenger. Then increase intracellular calcium level, and this is the last one. It has effect on vagus nerve and heart rate. Remember, in our anatomy we said the vagus nerve is the main nerve of parasympathetic nervous system, which comes all the way down from the brainstem to our neck, from the neck, then muscles of the abdomen. It's supplied to some organ like abdominal organs, but that is not our focus for today. So how does this digoxin target the sodium-potassium pump ATPase on cardiac myocyte? Digoxin specifically acts on cardiac myocyte, the specialized cell responsible for generating force needed for the heart to pump. Notice that the first in its mechanism of action begin at the plasma membrane of the cell, where the enzymes called sodium-potassium pump ATPase is located. Notice that the potassium ATPase palladium and then potassium that of the brain. It does it pump ICF here, and this is inside of the cell. It simply pumps sodium ions out of the cell and then potassium inside of the cell. It creates an electrochemical gradient, which is essential for generating electrical impulses that regulate the heartbeat. So basically, with digoxin interaction. Notice that when digoxin enters into the bloodstream, it binds simply just to inhibit. And we said inhibit simply to block, to inhibit the sodium-potassium pump ATPase on the surface of the cardiac myocyte membrane. And when the inhibition of this pump actually is prevent sodium from being pumped out of the cell. If you notice here, 3 molecules of sodium is initially constant going out of the cell, and 2 molecules of potassium are going out. So when we bind this from working, we stopped, that is to inhibit it. Basically, it stopped sodium from going out. So what will happen if sodium are not going out of the cell? That we are going to have elevated level of sodium inside of the cell, sodium ion inside of the cell. So when we have too much sodium buildup inside of the cell, this causes buildup of intracellular sodium, disrupting the normal ion balance. Why does this matter? Notice that when there is too much buildup of this sodium inside of the cell, it won't just sit down there doing absolutely nothing. It has to interact with another important ion, which is the calcium. And you notice that the calcium inside of the cell basically make the cell to contract. At the end of this video, I'm going to drop a link down below which I talk about the smooth muscle contraction. The steps, we explain everything there step by step, starting from signal, depolarization, etc., etc. Normally, when sodium leaves the cell, calcium is pumped out through a different channel, which we call the sodium-calcium exchanger. This channel is different. Remember, this is sodium-potassium ATPase pump, and this is sodium-calcium exchanger. The disruption of this exchanger makes the exchanger to stop working well. Remember here we have, calcium is coming inside of the cardiac myocyte. So when the exchanger stops working well, we are going to have the buildup of calcium as well. This is where things get juicy. Here we have calcium buildup in the intracellular space of the cardiac myocyte. So when calcium is, as I noticed that the calcium is what makes the heart muscles to contract. So when there is more calcium inside of the cell, the heart can contract more forcefully, and that is what we need. And remember, if you could remember, we said heart failure, inability of the heart to pump adequate amount of blood. And here, because of the digoxin, it follows this pathway. Taking a very quick review, it inhibits the action of sodium-potassium pump ATPase, which causes sodium buildup in the intracellular space. At that case, because of that, it interacts with calcium, activating another different channel, and that also causes the disruption of that channel, which is the sodium-calcium exchanger. So because of that, we have buildup of calcium in the intracellular space. The last but not least is the effect of digoxin on vagus nerve and heart rate. Notice that in addition to it directs on heart muscle cells, the digestive system also influences the autonomic nervous system, particularly the parasympathetic branches. Digoxin affects the vagus nerve, which is part of the system that controls our heart rate, particularly in conditions like atrial fibrillation. So how does all this help? Basically, slowing the heart rate gives the heart more time to fill with blood between beats, and this improves the blood circulation. So combining this effect, we can simply conclude and say digoxin helps the heart function more effectively. So this is it for this video. I hope you find it very helpful. Please, if you do me a favor by just clicking on that subscribe button. Thank you for watching, and see you next time. This tutorial is for those of you taking pharmacology as a course. In this video, I'm going to be focusing on this certain drug which we call the digoxin, though some people choose to pronounce it as digoxin. Digoxin or digoxin, regardless of how you pronounce it, feel free to write it correctly. We're definitely going to meet at the spelling. Digoxin falls under the class of cardiac glycoside. Specifically, it is a digitalis glycoside. Notice that the word cardiac simply means heart or anything related to heart, and this refers to heart function and health. Example, we have the cardiac arrest, cardiac surgery, and cardiac medication. And the word digitalis here basically is a medicine that helps the heart to work better. This common gland. Notice that digoxin presents like